Welcome to Black Hat Windows 2K Security, held February 14th through the 15th, 2001 in Las Vegas, Nevada. The following videotape was recorded live at the conference and produced by the Sound of Knowledge Incorporated. This is videotape number 6, Deep Knowledge Track, IPSec in a Windows 2000 World.
To IPSec in a Win2K world. My name is Raymond Forbes. Presenting will be William Dixon, who is program manager at Microsoft. He is solely responsible for the IPSec implementation. No, it's a huge team effort, but he is definitely the Superman as far as knowing how IPSec is handled on Win2K. Dan Kurc, who is a developer of auditing and penetration testing tools, and I am I guess a paid bad guy. I do penetration testing and I help design secure networks. Okay.
We'll have an agenda slide.
Yeah, this is going to be, we should probably get into that. This is going to be very long. Like I said, probably about 6 hours if we could, it takes that long. We're going to start off by going through the very basics of the protocols of IPSec, of Kerberos, the certificates, of things necessary to implement IPSec. And from there, we're going to do a pretty in-depth study of the IPSec protocol itself, including the Internet Key Exchange. And then after that, William's going to take over, and he's going to talk about the Win2K implementation. And he's going to go pretty detailed in that as well. And we're going to actually have some demos of setting up tunnels and setting up transport mode IPSec. All right, so we're going to start with the protocols basics. So the first one we're going to talk about is IPSec. IPSec is a security protocol that works at the TCP/IP layer. It provides two modes of protection, one that's called tunnel mode and one that's called transport mode. And we're going to get into each one of those as we go along. It provides authentication and integrity. It provides confidentiality, and it provides replay protection. Tunnel mode. Tunnel mode is specific. Tunnel mode could be looked at as gateway-to-gateway communication. Whenever you want to tie two networks together through IPSec, for instance, making a VPN or something like that. It's not really a VPN, but it's in that same model. It encapsulates the entire IP packet within the IPSec protection. And as you can see here, tunnels can actually be created between several different node types. The gateway to gateway, host to gateway, host to host. When you actually set up in Win2K, and if you try to set up a tunnel, they actually don't recommend it because they consider it kind of outdated. They recommend that you actually use L2TP and create a real VPN. All right, and here's an actual diagram of the three types of tunnels. As you can see here, we've created a gateway to gateway, and a host to gateway, and a host to host. One thing you'll find out is that you can actually run tunnels inside the tunnels. So we could be running a gateway to gateway tunnel right here, and then at the same time we can have IPSec between these two hosts. And we'll talk a little bit about that as well. Transport mode. Transport mode encapsulates only the transport layer information of the IPSec protection. As it says here, it can only be created between host nodes. This is really what you'll see inside a lot of intranets. Basically, you have servers inside your intranet that you want to keep protected, and this is the way to do it. It provides verification of the origin of data, and we're going to break apart a packet to show you where each one of those things sits. It gives you assurance that both the data and the network headers have not been changed in any of the data that's sent, depending on the protocol that's used. Provides confidentiality, encrypts data to protect against eavesdropping, and in tunnel mode, you can actually hide your data source, so they won't be able to figure out where exactly you're coming from. And this is a demonstration of the replay prevention window. How many people are familiar with how TCP/IP does its windowing? It's basically the same kind of thing. If you notice here, there's this, well, I got a 9-bit window, but it's actually a 32-bit window. So what happens as this packet comes in right here, all these packets, if somebody tries to send these packets in, they'll be dropped, and they will not be accepted. But every one of these packets will be accepted. N+5, if it comes in, will be accepted. N+8 will be accepted. But as soon as N+9 comes in, this packet will no longer be accepted, as the window will slide that far. And if this packet comes in right over here, then N+5 won't be accepted anymore either. Okay, so there are two basic protocols to how IPSec works. IPSec is defined a few different ways. There is an actual RFC very specific to IPSec itself, and there are two specific RFCs to the protocols that are used by IPSec. The first one is called Authentication Header. The AH, as it's called, authenticates payload data network header, and it gives the anti-replay protection. And the encapsulated security payload, ESP as it's called, encrypts the payload data and authenticates the payload data, and it also gives the anti-replay. And I want you to notice one thing here, is that authenticated header authenticates the network header, but encapsulated security payload does not. Whereas encapsulated security payload does actually encrypt the payload data, but it's not done with here. So you'll actually see this used a lot in combination, which will provide both the encryption and the authentication of the network header. Now, we're kind of glossing over some of this stuff, and don't worry, as we get into the more in-depth, we're going to actually break apart exactly how each one of these, what each one of these actually mean. So don't think we're going glossing over them too much. All right, so here's a diagram of an IPSec AH in transport mode. As you can see here, here's the original IP header, or the IP header, TCP header, and the data. And this is where it sticks the authentication header information right there. And as you can see here, the integrity hash covers this entire packet. And like I said, there is no encryption in here. So any sniffing would happen, they would definitely be able to see this. Now here's IPSec H in tunnel mode. And as you can see here, it adds another IP header with the source and destination IP address. That actually makes up the tunnel. And then it adds the AH header behind that and in front of the original IP header. And as you see, it actually does cover the entire packet once again. Now here's ESP in transport mode. And here you see this is usually encrypted. What it means by usually encrypted is you can actually define encapsulated or ESP to not use encryption. You can use it to either use authentication or encryption. But according to the RFC, you cannot do both. You cannot say no encryption and no authentication. I guess they felt it was kind of silly since it did nothing at that point. And actually, that's what it said too. So as you see here, it sticks the ESP header right in front of right behind the original IP header and in front of the TCP header, and it puts in behind the ESP authentication information. We're going to go into breakdown of what each one of those, what's inside each one of these things. As you see, the hash only covers up into the ESP header, so this IP header is not authenticated. So theoretically, it's possible that something could happen inside this part here. Do you have anything to add to that? Do you have anything to add to that one? Do you want to add anything to that? Okay. All right, so here's IPSec in tunnel mode. Once again, we have the encrypted data here, the integrity hash, and the new IP header to actually make up the tunnel. And you notice, once again, now we have the integrity hash covers the old IP header that was sent by the original, but the tunnel, once again, is not authenticated. Okay, so what we're talking about here is the actual logic that goes through IPSec when it makes a decision of whether to accept a packet or not. In the IPSec world, there are three possible decisions. There is permit, there is deny, and there's negotiate. And then when we set the filters up, you set them up either one of those three. When you set up negotiate, it goes through this exchange. From here to here. The first thing it does is TCP/IP contacts the IPSec driver and tries to determine if it's got what's called an SA that would sit inside the policy. And if it does not, it goes into the Internet Key Exchange, or IKE, to negotiate one. When IKE negotiates one, it hands it to the policy agent, and then the policy agent uses that SA, and we'll talk about what that is later, to then communicate with the host. And that's the wraparound that it has there. Dan? Okay. All right, the IPSec driver, its role is to monitor and secure the IP traffic. It does the encryption and the authentication of the outbound packets and the decryption and authentication of inbound. And it checks, and it actually contacts IKE to negotiate the secure channels. And also, like it says, maintains secure channel state information. Right, this is what's called the SADB, or Security, what's that word? Security Association Database. And we'll go into, like I said, the policy engine and the Security Association Database in our in-depth review. The policy agent itself maintains the IPSec policy and state information, and that's actually called the IPSec policy database. It distributes the filter rule sets to the IPSec driver, and it distributes authentication and security settings to IKE. IKE, which is probably the most confusing part of IPSec. How many people have actually looked into the IPSec spec at all? What did you think of IKE? Pretty damn confusing. It took a while to actually kind of get an understanding of how this worked. But what IKE basically his job is to do. So when they wrote the IPSec spec, they didn't really talk about how hosts would negotiate whether they should communicate with each other or not. So in a small world of, say, 2 or 3 systems, it's no big deal, right? You go to one machine, you set up, okay, I want to talk to that machine. Go to the other machine, I want to talk to that one. It works great. But what happens when you have 3,000 machines or 300,000 machines? You don't really want to be going to each one and specifying each one. So they had to come up with a way of doing key exchange and also secure what they call security associations, which is the policy that allows it to communicate. You need a way of distributing those. So they came up with IKE as one of them, and there are actually a couple other ones. IKE is based on the ISACAMP specification. All right, and as you can see here, this is how it all fits together. Is this animated? Is this one animated? Did you want to say what you're going to say? What was this? Well, I don't know what you're going to say on this one. What was the point of this one? What's the point of this line? I don't know.
This slide is showing what it is you're explaining in the next slide.
Okay, so as you see here, we've got our hosts, we got our gateway, we've got the internet. And we're going to go through this now. All right. So this is as we're sending out in transport mode. Hey, Dan, you do these slides.
What's that?
You do these slides. You wrote these, I'm not sure how you're doing it. I'll take it.
Okay.
Go by the microphone.
More or less how IPSec will work is the application sends data the way it would normally without IPSec. It actually has no knowledge of the below layers. It'll send things down to the transport layer. Still, nothing's different. Once we get to the IPSec layer, this is where that whole exchange with IKE and the IPSec driver happens. And in transport mode, it'll put the headers in the same format what we saw earlier. So then this is the way it's going to build out the packet here. Any encryption or authentication is going to be, or the encryption in an ESP is going to happen here. In AH, this whole, all 4 of these sets of data right here are going to be authenticated, and then it wraps it in the physical and sends it on the wire. Okay, and then when the router receives it, the way it first works is it's going to get the packet the same as it was sent. It's going to strip off the physical layer, which is left with the IP layer, so then we're now back up to the network layer. it's going to see that this IPsec information really doesn't apply to it. But then what it has is when it's sending data to the subnet, the destination subnet, it's required to go ahead and open up another tunnel. So then it goes out and it will apply IPsec again to this whole packet. And in tunnel mode, basically you take this whole packet and drop it straight down here, and then it will apply its IPsec. So if we are running an ESP, all of this will be encrypted. So then you actually have your TCP data and your application data will be encrypted twice by the two different hosts. And then it will wrap it with the IPsec, and all of this will be authenticated. So then to the wire, when this goes out on the untrusted network between the two routers, what you will see is this is a big opaque blob to everything else. This is going to be the encrypted data in ESP mode.
So we're describing actually two things. One is transport mode, which is like SSL, right? So it's end-to-end between a client and a server. And then what Dan is showing right here is when this packet is just an IPv4 packet that travels through the network. It looks no different than any other traffic. The only time you would run into problems with having IPsec in your network is if you were doing port filtering at some point, right? Because now the packet, the IPsec transport mode packet, the one that's securing traffic end to end, is IP and IPsec, and you can't see the ports. So if you were trying to route through routers and doing port filtering, you wouldn't see that. Did you like it in the chair? So this packet traveling in the internet or traveling across your internal network is just transport mode. It's just a regular IPv4 packet. And then what Dan is saying is that at the router's been configured to initiate an IPsec tunnel, which was the diagram that he showed 2 slides ago, to some other destination. So we're basically just going to tunnel this packet, whatever, all traffic, right? Not necessarily just IPsec traffic, but all traffic through the tunnel, maybe between 2 subnets. And so when the IPsec tunnel starts, right, what happens actually at the packet layer is you get the original packet that comes into the router, whether it's IPsec or something else, that matches the tunnel rule, then it gets put into the IPsec tunnel. So you can do, because it's just an IPv4 packet, it can be tunneled inside any other kind of IPsec tunnel. Okay, so IPsec is providing end-to-end security, and it's also providing router-to-router security in that tunnel. And that's kind of hard. I mean, just think of IPsec as a very generic mechanism to protect IP packets.
Actually, there's something I'm going to bring up. I'm going to go back a couple slides. One thing also to mention here, as I said, what we're showing an example of is a transport mode tunnel host to host and a gateway mode tunnel, whatever. That's a tunnel mode and this is transport mode. But one thing that's very important, while you can encapsulate these IPsecs within each other, they have to terminate before the next tunnel starts, which basically means you cannot set up a IPsec tunnel between this host and this router and then set one up between this router and this host. They have to complete and complete.
And on the same note, though, outside in the internet here, there can be any number of tunnels as long as they do terminate before this router. Okay. Okay, and then when the other security gateway gets the packet, it's going to look like this, and it's going to realize it has a security association with the other router, and what it's supposed to do is take the IPsec policy that it has set for this particular data flow and do everything that the other router did. So basically what it's going to do is unprocess this part of the packet, drop it straight down, wrap it with the new physical header, and send it right back out on the wire. So then what the final host, the final destination host, what it's actually going to get is the exact same packet that was sent out, with the exception of the physical header, which is now going to reflect the router. With its security association with the other endpoint, it knows how to process this data here, and it should be able to decrypt everything and see the traffic, and have it authenticated and decrypted on that host. Okay. You want to start? I'll start. Okay.
Okay, so layer 2 tunneling protocol. Layer 2 tunneling protocol is kind of the new, layer 2 tunneling protocol in combination with IPSec is the kind of the new VPN technology that Microsoft is working on. It kind of, they like it to replace PPTP. L2TP is an open standard that provides, once again, PPP encapsulation over IP, like PPTP does. And with that provides the VPN services. But what it does not provide is a method of encryption. It is very basic, and it does not protect against injection of packets into an open L2TP session. It's kind of interesting. If you actually have an open L2TP session, which is not possible in Win2K, you can drop packets inside of it. And you could just start doing whatever you want inside of that tunnel, and it will not even care. So I would guess specifically because its intention was to have IPSec as being the method of protection. Oh, right. Also, I guess one of the reasons why that's possible is because this is actually done in UDP and not in TCP as PPTP is. So UDP is pretty easy to spoof. Here we have a demonstration of how L2TP works with IPSec. We start with the application, or so start with the IKE negotiation.
The application in this case is just the VPN UI.
Right. You want that?
Yeah, I can do it.
I guess that's your slide.
So when you pull up the UI, right, you just create a new connection, and the connection type in Windows 2000 will be automatic by default. But what that means is it's going to try L2TP if you have a certificate, and if you don't have a certificate, then it'll try PPTP only. So basically, when it's doing L2TP, the application is just the VPN UI, and the very first thing that happens actually is DNS resolution of the gateway IP address, right? So you know what IP address to go to. And there's some automatic policy plumbing, which we'll look at later. But after that, then what we have to do is set up IPSec before the L2TP, because IPSec is going to establish a secure channel across the internet in this case between the client and the gateway. So in order to do that, the very first step is the IKE negotiation that is going to negotiate security between the client's internet address and the gateway's internet address. Okay, so after the IKE negotiation finishes, it has an agreement on cryptographic keys and security algorithms for the tunnel. It's going to talk to the IPSec driver and say, here's how to protect the L2TP tunnel. It's going to say L2TP is actually going to look like UDP 1701 traffic, and I want you to apply these encryption algorithms with these keys to it. Right. After that, essentially the application or L2TP starts sending the L2TP session setup. L2TP is exactly like PPTP at a high level. Basically, it's a PPP negotiation that will authenticate the user and do address assignment. Right. So then the tunnel will look like a PPP interface on your machine. So if you did ipconfig/all, you know, when the tunnel's set up, you'll see the internal IP address is assigned through the PPP negotiation. So basically, number 3 is data or traffic for L2TP starting to happen. Okay. takes quite a long time for the IPS standards process to work, and therefore we wanted to get something out in the market so that people could enable VPNs back in '96. So that's why we did it the way we did with some partners in PPTP. But then primarily with Cisco, we said let's take the best of PPTP and the best of Cisco's layer 2 forwarding protocol, L2F, and combine them together and make a really great VPN remote access protocol that will be an IETF standard. So starting in, a long time ago, basically 97, 98, 99, we've been working on L2TP with Cisco. And at the same time, IPSec was nearing maturity. A lot of the vendors that were not part of, did not have PPP implementations. They weren't part of remote access products. They were building solely a gateway-to-gateway IPSec tunnel mode router, and then they wanted to get into the VPN remote access. They saw their shortest time to market as modifying the IKE protocol to do remote access instead of using L2TP. So that's why we have essentially two different products in the market. Those gateways and those clients, like the Windows clients, that are based on the IETF protocol for remote access, L2TP. And other vendors that have decided to ship their custom clients with a custom version of IKE that will talk to their gateway, fine, that's all it needs to do, that does IPSec tunnel mode. Yes, sir?
Question has to do with site negotiation.
Yeah.
You just mentioned about the difference in standards, difference in deployments, and earlier we talked about site negotiation. Do those differences create problems for site negotiation between forums?
Well, anytime you're implementing something outside of the standard, it does present a problem. But I'll tell you that IKE by itself is very complicated. So even if you're implementing within the standard, you have to test interoperability for every single option that you support.
That's still going on in evolution?
Sure.
Evolution of IPSec?
Sure. The RFCs for IPSec, I guess, were completed. They finally reached RFC status in '98, December of '98. L2TP went RFC in '99, sometime, maybe it was, I can't remember, August through October sometime. So yeah, there's still evolvement there. And if you look on the IETF IPSec Working Group website, you'll see a bunch of drafts, which are essentially work in progress, and then you'll see the RFCs at the bottom. So I don't think people believe that they're done with IPSec. The wire formats are very much decided. They've been decided a long time ago. It's really IKE, how do you negotiate the security to get the wire format that's still sort of in evolution. What we tried to do in Windows 2000 was see where everybody was going and kind of divine how all this would work out. We were really clear with L2TP. We knew that was going to be a standard for remote access with Cisco. And ourselves basically authoring the draft, and everybody really excited about that. It's used in a lot of other places than just remote access. But the IKE part of it and the IPSec interoperability, because they modified IKE, then there will be interoperability issues. I don't think you can take a Cisco client and work with a Nortel gateway, for example. You can take our client and work with any gateway that supports L2TP IPSec. So that's kind of the difference between an interoperable solution. We were shipping a client that we hoped everybody could use in a very easy manner. And we can talk about how easy it is. Because we did require that you have certificates, because pre-shared key, usage of pre-shared key in IKE is very problematic, I'll say. But we can get into those details later. We did want to take questions as this goes. We got until 12 to talk about this section. So we really want to help you understand the protocol basis.
Yeah, you look at the UI and you set up L2TP and it just turns on IPSec. So.
Yeah, I mean, we didn't want you to have to do anything special for IPSec. When you bring up the VPN UI, do you have this in the slide?
No, we actually don't have the VPN UI.
At the break, maybe you can come up and look at my client. But the UI just comes up, and you just choose L2TP as a tunnel type if you want to choose it explicitly. And when you choose that, all the IPSec stuff gets generated automatically, right? We know the destination gateway IP address because we did a DNS resolution for it. We know that how to do the IPSec negotiation because we sort of hard code part of the policy, and we use whatever cert that you have as a machine cert on the box, and we negotiate the cert between the gateway and the client. Well, all that basically happens automatically. We wanted to be as simple as possible because our goal was to get people off of pt4, right, to migrate up. And right now, the only blocker to migrating to L2TP is the ability for people to get machine certs on the box. So in Whistler, the next release, we will be supporting a pre-shared key. Now, I say it's insecure, and I'll tell you again, it's insecure. In all my talks, I say using a pre-shared key is insecure. But the fact of the matter is, for small businesses, they can control. They only have a few clients going through a gateway, and why should they have to deploy certs? Right? So we support pre-shared key in the next release, and you'll see that in beta 2 of Whistler, which is now called Windows XP. You can try that out. Yes, ma'am.
You say it was hard certificate, only Microsoft certificate?
No, we'll take any machine certificate that you can get. We regularly test with Netscape, Intrust, VeriSign, Baltimore, basically all the certs that we can get.
Which format?
It's as basic a format as possible. The IPSec, let me just talk about the certificate interoperability problem, okay? The IPSec working group did not define a standard for how to use certificates in IPE, right? They defined a standard for how to do RSA signature authentication in IPE. So as long as you have a private and public key on both sides, right, it is technically possible that you could have an RSA signature authentication, if you will, right, between two systems. That's what the IPE RFC describes. Now, it also describes how to send certificates inside as what's called a certificate payload to the other side. So I have a cert, and I have some CA chain, and I'm going to send part of that chain and my cert over to the other guy. I'm not going to send my private key, right? But I'm going to send the public part, which is my cert chain, over to the other guy. Well, when people were developing IPSec, the very first thing they got working was pre-shared key, right? And then the next thing they started working on was certificates. And then the certificates just introduces for the implementer a lot more complexity, I'll say. Because now you have to worry about how are certificates issued, how do you get a certificate, those kind of things. So partly with certificates, and this is another reason why we're supporting pre-shared key in the next release, is with certificates, you have to be concerned about how to get certs, how to validate those certs. And that's independent of the VPN client. That's how the operating system can get a cert, and how an operating system can validate certificates. So, it does introduce a little bit extra complexity. So with Microsoft certificates, quote certificates, the thing that having a Microsoft CA gives you is the automatic enrollment of machine certificates if you're a member of the domain. Right? So if all your laptops or remote access clients are joined into a Win2K domain, because every Win2K server has a certificate service in it that you can use for the price of whatever you pay for the server is, right? But basically it's free PKI from, I'm not paying extra for PKI, it's just there in the box. So we wanted to make it that easy for people to deploy PKI, not having to pay a third party to do it. So all of you, if you're independent consultants or you run your own business, you can set up your own CAs and you can issue certs. If you're an independent consultant, you can charge somebody for it. I mean, the CA service is there in Win2K server. It's up to you to use it. But for things like remote access, we made a security decision that certificates were the only secure way to authenticate the client. And we didn't want to back off on that, and so we shipped Win2K using certificate authentication only for L2TP for the IPSec part.
One thing I'll mention here is that auto-enrollment thing I thought was very cool, and I think we'll show a little demo of how to actually set up the auto-enrollment of machines with certificates. Because when you have a large environment and you've got yourself huge Windows 2000 with an Active Directory infrastructure, being able to do things like auto-enrollment and other automation is quite helpful, and it makes it an actually feasible thing to do.
Well, able to get certs and make sure that our PKI group, I mean, they have to do the same thing, right? Because PKI is a very general capability in the operating system. They've got to work with all the third parties too to make sure that the certs, they can get certs and the certs that they do get and be validated properly and changed properly and all that. So we will work with third parties. In order to get a cert from a third party, like the Entrust 5.0 connector, web connector, has the ActiveX controls in it so that you can just enroll off a web page. And VeriSign will have the same thing if it's not already out. I apologize to VeriSign folks if you're hearing documents. I don't know the exact product version that they support the ActiveX enrollment. But basically, to get a cert, you're admin on the box, you enroll for the certificate using the browser. So yes, any third-party CA should work. If you have problems, I have lots of cards you can send me now. Because I love people using IPSec and it pains me if it doesn't work for you.
Did that answer your question about the certs?
Yeah, I was curious as to which certificates, like, you know, VeriSign, for example, you can purchase the various different types of certs. Like, it doesn't have to be.
Right.
Oh,
Right.
Okay, so the type of cert, it has to be an RSA signed key pair because that's the standard for negotiating in IPE. It's got to be, we did make it a minimum requirement that it has to be a 512-bit key size or greater. All this information is in my walkthrough, which is on the web, so you want to definitely look at it because it's basic. So 512-bit key size, it's an RSA signed signature key pair, or RSA key pair, not a DSA key pair, for example. It should identify the machine, but it doesn't have to, right? When you use it, it has to chain to a valid root, so that whatever root ultimately issued this thing, or the trust chain changed back to, your box has to be able to trust it. And if you're going to give this cert to somebody else, well, they better trust the same root. Right? But it will work in a cross-certified environment, so if you've got two roots, you can issue cross-certification certificates. One guy trusts the other guy, and the other guy trusts the other guy, and you have that configuration on your box, and it'll work.
So, how do you secure the certificate for auto-enrollment?
In Windows 2000, so first of all, it's only for machines that remember the domain. And the reason for that is it's a Kerberized RPC that is required to be encrypted with, I guess, it'll be RC4 is what RPC uses for encryption. If you've installed a strong cryptography pack, it's 128-bit crypto. If you haven't, then it's either 40 or 56-bit. I can't remember.
56.
Okay. But then it's actually because they wrote the enrollment card is just a sort of an application, sort of enrollment application running as a service on the box. It uses DCOM. So it's an RPC encrypted DCOM communication. Now we had to cook this up because the enrollment standards were not there in 1997 and 1998 when we had to have something working and in beta to use. So once we had implemented this custom enrollment protocol, it worked. We shipped it, but we don't want to publish that because it's custom. It's RPC and it's DCOM and it's ugly. Okay. So what we want to do, and in Whistler we're supporting what's called CMC, which is certificate management something, but it's basically the RFC, one of the RFCs for certificate enrollments, which we co-authored with VeriSign. So in Whistler we'll be able to do CMC-based enrollment for certificates. The machine auto-enrollment stuff, because that's already working in Win2K, and we had such a short delta to Whistler in terms of the amount of development change we could make in the system. Machine auto-enrollment will still use this DCOM RPC mechanism. But there will be ways that third parties can plug in, and if I had the PKI guy here, he could explain exactly how. But basically, think that when Whistler ships plus 90 days, right, all the PKI vendors will have everything they need in order to do auto-enrollment of certs. And the plus 90 days is just to give us documentation time to get it out there and work with the vendors. Okay?
You're going to go in later how the certificates are stored on the machines?
I can talk about that, but I'm not the expert in it.
We don't really we don't do that, do we? We talked a little about certificates, but we don't talk about how they're stored, really.
Okay, let's see if we can get through this section, and then if we have some extra time, I'll go into
Right.
certificate.
Is there any more questions about that we got so far? Okay. Okay, so the next thing we're going to talk about is Kerberos. We're going to briefly touch it because it's important to IPSec and Win2K. William mentioned that you can use pre-share, or you can't use, well, you could, with regular IPSec tunnel or transport mode, you can use pre-shared keys and you can use certificates, but you can also use Kerberos. And this is the default way that Windows 2000 uses IPSec originally. So if you try to set up a host-to-host communication on your Win2K network, it will by default use Kerberos.
That's really for end-to-end.
Right.
Right? So if you're protecting clients or servers, it's up to you to define the policy. You can define it however you want. But because you already have a trust group with a Kerberos server, and all your machines are members of some domain and they're members of a KDC someplace, they have Kerberos credentials, why would I make you deploy PKI in order to deploy IPSec? That didn't make sense. So back in '97, actually, when we shipped beta 1 in August, that was the very first thing we had working. We worked with this whole IPSec in Windows 2000 was jointly developed with Cisco, and there was a guy who worked with Cisco at the time, Daryl Piper, who is now gone on to other things, but he is the author of the draft, the IETF draft that describes how this works. So what we wanted to do was basically Kerberize Ike. Okay, so Ike does all the stuff that Ike normally does in the RFC. It just uses Kerberos to establish trust, right, for authentication only between the two end systems. So what that enables is that as soon as you join a server to a domain, and as soon as you have clients in the domain, you can turn on IPSec, and you don't have to do anything else. No pre-shared keys, no certs, just turn it on, and you have a very strong Kerberized IPSec trust relationship between the machines.
Right. But what that also means that if you try to set up IPSec between two machines that are not in the same domain, just by turning it on, it won't work. It'll actually fail. So it takes a little bit extra configuration, and that's something that we'll go into as well. So let's talk about what Kerberos provides. Kerberos provides authentication of network, server, and client, and it allows mutual authentication of parties, a much stronger method of authentication using the mutual method. What it does not provide is encryption. If you think that your network is encrypted because you're using Kerberos, you're wrong. Well, all it does is provide the authentication. If you want the encryption, you have to turn something like IPSec on. What's that? And it does key exchange, basically. Okay, so let's discuss what we have here. This is a very, very simple Kerberos environment. Right here, what you have is the Active Directory environment. You have here what's called the KDC, or the Key Distribution Center. This is the location of the central location of all the actual keys. Now, the KDC in Win2K is part of the domain controller. You cannot separate it out. It's just the way it comes. A KDC is made up of two components: AS, Authentication Server, or Service, and TGS, Ticket Granting Service. And then we have here our client network application. And then we'll talk about how this, now we'll do. So, the first thing that the client does when it logs onto the network is it sends an authentication request to the AS part of the Key Distribution Center. It then checks its little key database, makes sure that it's all cool. It's integrated, like I said, with Active Directory, so it actually does a lookup in Active Directory. Which then, at that point, the KDC sends back a ticketing granting service. That ticketing granting service, ticketing granting ticket means that that client is now allowed to ask for tickets. Tickets are what Kerberos uses. That's what it communicates to different things with. That's its token, its authentication method. And at this point, this client is now allowed to connect to resources on the network. So the next thing it's going to want to do is it wants to hook this application server. Say it's a print server or something like that. It sends a ticket request to the ticket granting service saying that I want to talk to this client right here. The first thing the KDC does is it looks up in Active Directory whether it's responsible for it or not. Now, one thing I'll mention here that we don't really have in the demo, if the server that you're trying to connect to is not in this domain, but is in a trusted domain, it will actually forward this request on to the domain controller of the domain responsible. In this case, we are in the same domain, so it sends back a service ticket. The then client has a three-way negotiation with the application server, which then validates this communication, and so hence the authentication happens. Is there any questions about Kerberos? Go ahead.
So it handles all things that are part of the Active Directory. I want to access the file server, I want to access the printer. Does it handle such things that go to legacy? I go to command line, spend a lot of time there, and I go to a share, whack, username, whack, printer. At that point, am I still using Kerberos if both of those machines are part of it?
So, oh, you're going to say that? Oh, yes, it does. It depends on what's going on, right? It depends on how your environment is set up. In a native mode Windows 2000, then effectively, yes, the authentication is going to happen over the Kerberos. But if you have mixed, if you allow NTLM or NTLM v2, then you're going to have the communication over those protocols.
Remember, we didn't ship a Kerberos client for NT4 or Windows 95 or Windows 98.
Right, so you're going to a legacy device.
No, it's more than just having a legacy device. If you allow legacy devices on your network, because the protocol is not, you cannot set it up so that you can do Kerberos to some machines and NTLM to others. It's either on or it's off.
Right. So for all Win2K machines, it'll use Kerberos, right? I should say, for Win2K machines, remember that if it can do Kerberos, it'll do Kerberos. And do Kerberos only. That's the way to think about it. If you've got a standalone machine which is sitting out there in the network someplace, and you need to access its file shares, it's not a member of the domain, then you have to basically do NTLM v2 authentication. Same thing you do, well, not for file sharing. I mean, basically every protocol had to present some user hash and way to identify the user. It's what NTLM v2 is. So we typically use NTLM v2 to authenticate the user to the remote system. Like if you were going to log on as local admin, right, to get access to a share, or some power user to get access to a server share someplace else. So for down level and also for Win2K boxes that are not members of the domain, it'll use the old method.
Can a client be part of the Active Directory that uses Kerberos, but when it does have to access its legacy, or think it is part of the Active Directory, or is not using Kerberos, is the client lost? I mean, I do one or the other, not both.
Yeah, imagine the client as the RPC service, for example. The RPC service will recognize and that's even a little bit, depends on what's using the RPC service, but the RPC service is Kerberos. So if it can use Kerberos on the remote system, it'll do it. If it can't, then it'll fall back to NTLM v2 or whatever the allowed mechanisms configured on the security policy in the box.
Kind of a follow-on to this is, at the root of our authentication mechanism here is we've got to raise management pass and tickets back and forth, but we still rely on passwords.
What's that? Oh, still relying on password.
Yeah.
Okay.
Well, the initial authentication still relies on password.
But there are mechanisms out there like RSA Secure ID, where it's a two-factor, one-time password generator. Can I plug that into this system?
Yeah, there's actually, you can, for instance, you can use smart cards. And there's a way to use smart cards. There are, Windows 2000 has provided a couple. I don't think I'm not sure if it uses a secure ID or not, but I know it uses the smart cards. I think it actually does use secure ID, but I'm not positive. But what's that? Yeah, I mean, I know Microsoft was working with secure ID a lot, even just 2 or 3 years ago, trying to set that up.
It's part of your logon process when you get the logon screen. Imagine the client here in this picture being the logon daemon or the logon process. So yes, you can enter your password, but you can also do a smart card only login.
Right.
In which case, and you can require of users that they only log in with smart cards via domain policy and other mechanisms.
Not only that, there are hooks for third-party stuff. So there theoretically is possible that you could set up biometrics or anything like that. You don't actually have to use passwords.
Just going back, the hard part was, if you've got secure ID, sure I use it, my gene has been changed, and I use that to log on to the domain, my initial login screen. But then if I go, again, back down to command line, where I do something like fire up user manager and connect to another machine, it's using the domain credentials.
smart card, or there are weaker ways to do it, like with a password. But once you have Kerberos credentials, now all the rest of the system services will use Kerberos if they can.
Right.
I want to make sure that you understand, in this diagram, this authentication request happens only when this client logs onto the network for the first time. This does not happen for every exchange. Once it has that ticket granting ticket, then all it needs to do is make the ticket request and get the service ticket and connect to the other machine.
So, the,
Part of the protocol is that this ticket has a lifetime and it
yeah,
can do it.
right.
Right.
The ticket granting ticket has a lifetime on it. Yeah.
You know, one of the things that's easier, that's not client application, that's the security package on the LSA running on the workstation. So it's not the client application, it's the operating system that's running the workstation doing that.
It's the Kerberos SSP, technically,
It's
right?
SSP, it's
Service,
so
security
you're
service.
right, it doesn't matter how you connect to the next server, it's gonna select Kerberos if you can.
Right.
Right.
Just use NTLM if you can.
Exactly.
The thing is, when you take workstations in the domain, including NTLM, things that it can't help Kerberos.
Right.
Exactly. You can actually shut that off. You can tell it not to use NTLM, period. Yeah, that's right. Has its benefits.
Structure, I mean, I could have a Linux active LDAP structure that's trusted by my Active Directory or NDS or something like that. But then it's trusting those other structures, so you're not just locking it.
Right. Well, I mean, yes, you can set up Kerberos trust between Unix and we've done that before.
You mean the MIT Kerberos for Linux? Yes. And I know that the guys that built the Kerberos implementation in Win2K had a very big effort to make sure that it was interoperable with existing Unix-based, basically, MIT distributions. There are just ways you have to configure it. There's a step-by-step guide on the web that tell you how to configure it.
Actually, as a side note, bringing up Unix, in the notes it said that we were going to show a Unix interoperability, and unfortunately my Unix kernel will not build, so I'm not going to be able to do that.
We'll show you the configuration
Yeah,
on the Win2K side.
yeah, we can show the Win2K configuration, but I mean I can't even get the kernel load anymore, so you can thank FreeSWAN for that. Anyway, what's that? Actually, I used no, I used SUSE, and then I tried to install FreeSWAN. All right, so is everybody cool with Kerberos? At least as far as what we need to know about it?
I have a question.
Sure.
I'm assuming that SMBs turn off after the work. Okay, I heard NTLM 1 and 2.
No, SMB is not turned off. It just doesn't use NTLM.
So it goes all the way down to that.
Yes.
You can turn SMB off first, and you can turn off NTLM 1 and then 2, depending on you have an environment.
SMB is the protocol for file sharing.
Right.
So that it's different from the authentication method used within that protocol.
Right. DLM authentication package.
Yes.
Like a backbone.
Okay, yeah.
Right. Yes.
But you can turn off each one of them.
Right, yeah. Yeah, basically you can go into the security template and quote group policy, and then you can set all those, they primarily apply to SMB, although they say all communications.
Yeah, we're going to show a demo of the local security policy and how to make that a group policy and how to turn IPSec into something you can then mask across your entire domain. As long as William helps me with that part, because I'm not sure group policy.
But, you know, the bottom line here is that every single protocol had to solve some authentication. And the value of IPSec in the platform in Win2K is that if you don't like it, right, if you think it's insecure, you have to use LM hash for some reason. As long as there's an IPSec implementation which can go underneath of it, then, you know, now you just, by order of magnitude, maybe more, increase the security of your communications across the wire.
So other, do you have other clients like that?
I don't know if there's an IPSec client yet that Apple's shipping for the Mac, but I know that BSD and a bunch of the Unix implementations have IPSec clients.
Right. There's like I said, there's one called FreeSWAN. That is a free distribution of of IPSec over the core Linux kernel. In fact, there's a few versions of Linux that actually ship with IPSec built into the kernel already. Not only that, there are, in the RFC they do specify a couple of things. One thing that's called bump on the wire and bump on the stack, or bump in the stack. Basically just third-party hooks into either your stack for the, if you're doing host-to-host transport mode, or, and it doesn't support IPSec, or bump in the wire for your gateway-to-gateway, and there's no IPSec functionality in the operating system already. Now, I actually have not seen an implementation of either bump on the wire or bump on the stack, bump in the stack, but theoretically it's possible according to the RFC.
Yeah, there are a couple of different IPSec clients for essentially NT4 and down-level Windows that basically do that. They install a client, right, as an Indus mini port or as an Indus shim in some way, and they intercept packets basically down below IP and do the same thing IPSec's doing in NTK.
Okay, so did that cover IPSec? I'm sorry, Kerberos. Okay, we're going to talk a little bit about public key infrastructure basics and what it provides. Public key infrastructure is basically the tools and methods that are used to establish the centrally managed certificate repository. Now, in Kerberos, we have a key depository. Certificate authority, or public keys, are somewhat similar, although Kerberos basically is just a shared private key. This provides us with a public and private key infrastructure instead of centrally managed, using what's called a certificate authority. It uses a trusted third party, and it provides mutual authentication of hosts, and it's platform independent.
Which one do I want to put his stuff on? He's going to show us what you're talking about while you're talking about it.
The public key stuff? Yeah. Oh, okay, so grab that one, I guess. Doesn't matter. Okay, let's give us a second here. We're going to...
Actually, we probably want to go on this one.
Okay. Yeah.
We're just going to show you some pictures while he's talking about some of those things to make it clear.
Sure, go ahead.
On your line there, it provides mutual authentication of hosts. Is that a common role of certificates that you're verifying the hosts that you're talking?
That is how IPSec uses it. So I was making these in specific to IPSec, but it does, it does a lot more than that. We'll talk about what's actually inside of certificates here in a second. Are you reading your email?
Well, that wasn't too good, but... Okay, so sorry about that. We're on certs right now, right?
Yeah. Okay. Or no, we're actually on PKI, but we'll get to certs.
Okay.
Okay. And it said platform independent. And here is a very simple diagram of how public keys are actually used in authentication.
Yeah, I will.
So what originally happens, as you can see here, is that the CA actually issues a certificate to the server, and the server then stores the certificate locally on itself. Oops. Got it. If the server tries to, this is a server trying to authenticate client, as in, for instance, an SSL connection. Or, oh yeah, client trying to authenticate the server, actually, as in an SSL connection. The server then passes the cert to the client, and then the client just checks its own trust list and verifies whether it trusts the CA that issued the certificate. And that's all there is to it. Okay. All right. Oh, very nice. So, yeah. Oh, you want to speak?
Okay. Also, back on that slide, not only does it verify the trust of the CA, it also verifies the cert. It verifies the signature that's contained in the cert to verify that the cert is valid. Then it checks the expiration dates on the cert as well.
There's like 5 or 6 things I think that have to be true for the cert to be valid. One of them has to be is that it's the domain that's on the cert itself. And there's a few other things that I can't think of now that it have to be correct, otherwise it'll throw a flag saying this is an invalid cert. Okay, so these are the things that are actually in a certificate. You have the information on the certificate authority that was responsible for the authenticity of the cert. And we see that right There's the public key. As you'll see here, it has the public key of the certificate holder, and there it is right there. It's RSA 1024-bit.
So I'm looking at my machine certificate right now, but it would be the same thing for a user certificate.
Right.
We're using an MMC snap-in to look at the certificate store on the box. So I, as local admin, can look at the local computer store, and then if you see right here, there says certificates current user. That would be my user certificates based on my logged in user ID. So here, there's the public key, which in this case is RSA 1024-bit. There's the subject name, which is what's called a distinguished name that identifies who the cert was issued to. In this case, it's my computer. And so there's the issuer, right? This is the distinguished name of, yeah, just covering the things that you
Right,
did.
no, I thought there was more things I added, but
Oh, okay.
the OID I thought I added, but I don't
Right.
see it now.
There's the issuer for who issued the cert, and then there's the expiration time, valid from and valid to. So this cert was valid from December 11th, 2000, 5:36 p.m., and it's valid to September 25th, 2001. Right, that's the validity time of the cert. Now it can be revoked before then, but if it's not revoked, then this is how long that cert will essentially be good for. I'll have to get a new cert sometime before then if this cert allows me to do anything.
Okay, and then also one important thing that's included in the certificate is what exactly that certificate can do. Now, certificates have responsibilities. Win2K, the way I see Win2K define it is email, EFS, and what else do we have there?
Yeah, the key usage here.
Okay.
There's a
The
bunch of-
digital signatures, whether it can do code signing, things like that. And as you can see that there, you can
Yeah.
actually change it sometimes depending on the cert.
Right. There's all kinds of different purposes, but the purpose is defined by this long number right here called an OID in the cert. So client authentication has a well-known, agreed-upon, standardized long number, an OID, and server authentication has the same thing. IPSec usage has the same number right in there.
Can you show them the trusted root certificates real quick?
Yeah. Okay.
Are we done with certs? Oh,
Well,
yeah, okay.
there's a certification path.
Yeah.
Do you want to talk about?
So what we have here is the way certificate authorities work, and it's something we're going to discuss in the next slide, is you can create subordinate certificates. It's a hierarchical environment. And as you can see in here, what we have is we all go all the way up to the root CA that was developed, and it was mandated out below that.
Right, so this entity cert, which is my laptop cert, was issued by that issuing CA. It's not a root, it's just a issuing CA. It's actually the online CA that I auto-enrolled with, right? And then that was a child CA of another intermediate CA, and then finally there was a root, right? So the root CA is where where the core of my trust is. I don't really trust these intermediate CAs. I only trust them because I trust the root CA. And so if I view the certificate of the root CA, it just tells me, in this case, it's the NT development root CA, when it was issued, when it's valid. It has the same kind of details. It's just a certificate. The only difference is the issuer is the same thing as the subject, right? So basically, a root issues a cert to itself, and that is the root cert.
The certificates are interesting because basically a certificate is nothing more than a template that things are filled in that provide the information. There's not a whole lot that's different between a root certificate and a machine certificate, other than some details actually in the certificate.
And one thing that we need to make clear, when you are actually authenticating clients for IPSec, you don't have to share a trust of the CA that issued the certificate. It's just they need to share a root, trust of a root, so they can follow it all the way back up the hierarchy. As long as they trust the same root, then they will trust the certificate for that machine.
Right, so in this case, NTDev issue 4 CA was the CA that I happened to contact to get my particular machine cert. But somebody else in a different domain would have a different issuing CA probably. But it'll all chain up to the same root, if you design it that way. So as long as you have a common root, IPSec will be able to establish trust. Yes?
I know you're using
not, yes, you can. What explicitly trusting a cert creates a certificate trust list, basically issues a cert off your own machine. And you can explicitly trust a machine cert, but using that in an IPsec negotiation, that you can do it, but it would not be common. Well, the problem is you have to agree on a common root. And if you can't agree on a common root, then the chance of you actually communicating is low. Yeah. Yes, because it's one way. IPsec is mutual authentication. So the IKE protocol itself has a way to negotiate just the root, right? Do we have I mean, we actually send, when you configure in policy, I'll talk about it later. I mean, we have some more slides later to go in the configuration. Yeah, you have to get the cert somehow already, out of band to IKE. That's correct. Completely out of band of IKE. You have to configure the certificate infrastructure, and then you can tell IPsec and IKE to use it.
Right, because IKE relies on the certificate on the machine.
Okay, so what happens if somebody trusts a cert that's out of band exchange with one machine? And somebody trusts it and they're not using it.
Most likely. We'll look at the UI later, and you'll see that you can specify a root in a list of roots. And as long as the, quote, root, which would be your CTL, is there, and you can agree on a name, then it'll be fine. So I can follow up with you later.
I just want clarification on that, because I just thought I found something.
Okay.
As long as it's in either of the trust paths, not just the root itself, right?
Yeah, the agreement is between roots in the IKE negotiation, but as long as you have as long as there exists a common root between my PKI chain and your PKI chain, then it should work.
But I think it's explicitly trusting, like I said, is exactly trusting problem I don't have. So I'm gonna override that and trust it anyway.
I know, but you do, in the IPsec session setup, there's no way, you don't get prompted, right? The application not using this, it's not controlling it, it's sending data. And this is happening in the background, done by a system service. So it's not the case, you can configure explicit trust, and then you have to go into the IPsec policy and say, treat this explicit trust as a root, okay?
All right, so we're going to mention the 3 types of certificates that exist. There's a Class 1 certificate. This is the lowest trust and verification. Basically, if you have an email address and $5, you can get one. I think it's 5 for shipping and handling.
For making money.
In fact, you can send the $5 to me and I'll get you a Class 1 cert. But anyway, like I said, you only need to actually have a valid email address to be able to get one. Class 2 cert is a higher trust and verification cert. You actually need a third party to verify that you are who you say you are. And a Class 3 cert is the highest trust. This is one, I'm not sure if the VeriSign person's in here today, but she was telling me that this is very rarely handed out. You have to prove you exist in Broad Street and Dunn and prove that you are the corporation that you say you are, and it's a really tough cert to actually get. But
So yeah, what we're talking about roots, and we're also talking about the certs that are issued under those roots, right? So the root is typically established, as you'll see in the VeriSign case, for Class 1 issuance. So all the certs that are issued off that root will only be valid. Your trust is only that they have a valid email address and have $5. So
shipping and handling.
right. But if the cert is issued off a Class 2 CA, then that's a stronger degree of assurance that the person is who they say they are, or the machine is who it is, right? And then it goes up from there, Class 3 and then Class 4. And
Class 4
VeriSign
is not used.
Right. So basically, I don't know the class system is standard, but PKI vendors will try to convince you otherwise, right? But basically, you have to look at the issuance policy of the root. Who does this root issue certs to? Who does the root establish child CAs with, right? In the IPsec case, that's correct. You're trusting the thing behind the IP address, which if you're using certs to identify for IPsec authentication, would be the machine. So, yes.
Is the root certificate a class unto itself, or does it follow the class type?
It doesn't really the class type is kind of a, I mean, they don't really describe it this way, but it's kind of this, I don't know what the word, kind of a random thing they chose to kind of give you an idea of the authenticity of the person behind it. It's not like they're, arbitrary. It's an arbitrary thing, really. You can't really assign a class to a root because you're already trusting the root explicitly. Otherwise, if you don't trust the root, you're kind of in trouble already.
Yeah, just think of class as a statement by the root, by the people that run that root, as the degree of assurance that they're going to take when issuing certs. It's Thank you. It's a level of due diligence.
All right.
There's another question on
How
this.
does CA one? One's gone.
Okay. Well, so
All right. So go ahead and start questions. Go ahead. Do you have a question?
I wanted to show you that you can in Windows 2000, when you look at a root. So let me just back out. What I'm showing here may not be too clear. It's a MMC snap-in to look at certs for the local computer. I'm looking in the Trusted Root Certificate store. So Windows 2000 ships with most of these. I can't remember the exact number because I've got some extra. There's 130 shown here. But most people think the browser is shipped with Trust. It's not the browser per se, it's the PKI module, right? The PKI module is shipped with what's called baked-in trusted roots, and this causes a lot of people some heartburn because you do, by default, trust all these people. Windows 2000 will probably be, well, I'll just say that in the next release, as a result of PKI taking off in the world, we receive requests from every country in the world to put their root in the Trusted Root store. And there were countries that didn't want to trust other countries. And it got to be a nightmare. And it basically boiled down to the fact that we will not be canning or baking in as many trusted roots as used to be. Now, I can't say that we're not going to do it because I know there's existing business relationships and contracts, and you know, your SSL site wouldn't work if you didn't have it, right? For consumer protection, if you will. So I don't really want to get into the philosophical debate on that. I'm just saying that the number of trusted roots could potentially be very large, but in the end, you decide what roots you want to trust.
You mentioned the whole IE thing and how people seem to think that it's actually IE that ships with these.
Right.
When you actually go into IE and you click on the certificates button and you pull up all the list of certificates, it's pulling it from the exact same place this is. So any work that you, what's that?
Yeah, I'll pull it up.
So any work that you do will affect both.
Yay. And I'm going to show proprietary.
What is that? What does that mean right there?
That's my internal portal, which is cached for offline use. So you would see whatever it says.
You guys have a link to Microsoft.com?
Anyway, if I go into certificate configuration, actually it's under content here.
Yep.
Certificates. So this is IE providing a user interface to the PKI storage and configuration. So if I go under certificates, this is actually a list of my user certificates that I see here. And if that's the first tab, it says personal. These are my user certificates. I can go to other people and you can see everybody I know who sent me secure email. Intermediate certificate authorities are these child CAs that I need for various reasons for chaining. And then I can see trusted root certificate authorities, which is the same list that I'm looking at if I go over to this view. Okay? So there's just two different ways to view the same information. IE provides a user interface to do it because they ship on all platforms, right? The operating system provides a way to look at it via the certificate management snap-in. And I can delete these guys. I don't know who this is, but well, doesn't matter.
Class 3 public primary.
Gone. Okay, once it's deleted, I can't get it back. You know, I've got to download it off the web somewhere. So if I ever run into somebody that was Class 3 certified, you know, if I was doing an SSL session with a server that was issued a Class 3 certificate, it'll pop up and say that the root's not trusted. And IE provides you a way to trust, right? It'll say, do you want to look at this certificate? And if you want to add this to the trusted root store, add it to the trusted root store. So if you think about it, actually having a somewhat secure business relationship between Microsoft and these other PKI vendors so that we know the right certs to put in because they gave them to us, that's a little bit more secure than your users just being asked, hey, do you want to trust this root? And they say, sure, trust it. And it's, you know, actually hacker.org running it, right? And then they're going to prompt for the user's password, and the user's going to give their password, and now your network is less secure. Yeah.
With that in mind, what rights does it take to add one of these certificates? Does it require parameter or administrators?
Well, it depends.
Yeah,
It depends on what kind of cert you're adding. If you're adding a user cert, you have to be a user. If you're adding a machine cert, you have to be administrator on the machine.
So basically, it's going to be exploited.
Boy, that one's come up recently, and I don't necessarily agree with that. That's a philosophical issue.
Well, if you don't have the trusted root there already, then you have, and IE pops up a question that says, this guy is not trusted, right? I don't have this trusted root in the store already. Right? First of all, there's cert validation. Cert validation will fail because you don't have the trusted root, right? And then it'll claim to be some trusted root. Remember, there's no universal organization in the name of CAs, right? You could set up your own CA and call it VeriSign if you wanted to. They click yes.
Right.
So this is the risk if you don't manage the trusted root store on your systems for your users. It is the risk that you run that they can auto-populate. Right.
Yeah, that actually has been coming up a couple times recently. There's a couple of what do they call them? Some of those response certs in other countries that don't actually like that very issue, and it's kind of a philosophical issue because you got to have the ability to put in certs to be useful.
Right. So, other questions about the protocol, about certificates? Kerberos?
In what situation? When he's first establishing when he's getting a certificate?
Yeah, say a meeting in the previous situation where he's trying to verify
That will depend on the CA. Some of that information will depend on the CA, what they require in order to issue a cert. There is the standard template, which we don't have a search over here, do we?
Well, we don't have an internet connection, so I can't show you the, maybe I...
But I'm not totally sure I'm understanding your question.
Okay, let's say it's an untrusted root.
Okay.
And let's say host is going out and he gets prompted first. You want to accept this certificate or trust it.
Right.
At that point, what information does the host have to provide to the certificate authority? And then
So actually,
An IP address.
he doesn't have to provide. I mean,
All
he
he
doesn't
does
have to provide anything. He's just
All he
handed a
does,
certificate.
he sent the cert, and that's all. That's it.
Right.
Yeah.
So there's no actual communication with the CA. When you trust a CA, it's not like you go back to the CA and say, should I really trust you or anything like that. All you're handed is a little piece of data that either is some kind of, standard certificate format that's basically a signed file that you can say, I do want to trust this or I don't. That's all there is. They're really...
Well, that... Yeah, there's two issues. Wait, stand by. There's two issues. He just talked about your decision, what is a root cert, right? And what does it look like? And when you import it, what is that? And it's a cert, right? It's in a cert format. It's got a signature and it's got a private key associated somewhere else, right? But you see the public key for that private key in the cert. But you ask about enrollment, right? So if I want to get a cert, there is information that the CA needs from me in order to issue me a cert. That may not be in the enrollment request, or it may be included in the enrollment request. Typically, it's included in the enrollment request, but there's many different ways to do it, and that's why the enrollment protocols took a long time to standardize. So basically, at a minimum, I'm going to generate a public-private key pair myself, right? Private key stays in my protected store, which I had a question about earlier, so I can talk about that now if you want. But I'm going to send my public key and other information in my request to the CA. typically it'll be some authenticating information, right? Like, well, authenticating means I am who I say I am. So you gotta solve that problem, and there's just too many different ways to solve that problem. Somehow the CA, and it's dependent upon the CA, it's dependent upon their issuance policy, right? How much information they need about you in order to issue the cert. Sometimes it's your name, your address, sometimes it's a social security number, sometimes it's your business license number, your Dun and Bradstreet number. And the list goes on in terms of the amount of information that you have to provide a CA to get a cert. But the actual enrollment request, at a minimum, only has to include your public key. Because the CA is going to issue in the cert whatever it wants. It doesn't have to use the information that you provide in the request. The only thing that matters is a public key, because you've got the private key, and that has to stay the same. So you could, if I'm a CA, you could request a cert from me and provide me all kinds of data, tell me you're Steve, and I'm going to say, nope, I think you're Bob. And I'm going to issue you a CA that says you're Bob, and that your public key and your private key now correspond to a cert that I issued, and you're called Bob now. So that's why it really matters who issues the cert. Typically, in a Win2K environment for auto-enroll, I was going to show you the just a web page enrollment.
You're disconnected.
Yeah, I know.
Oh, okay.
I had
You
to
did it on
find.
purpose.
Yeah, I had to find.
Oh, you're going to show them the enrollment?
Yeah.
Okay. I actually have, okay.
Okay, so this is a file. This is, look in the search results here. There's a file called certrequest.hta. It doesn't ship in the platform, but it's available from MSDN as a sample, and it's available from our website to download. All this is an HTML file that's sitting on my disk. All right, and I double-clicked on it, and it's running IE. If I look at, you can't tell necessarily that it's IE, but it's basically an HTML request page. If I were to look at the source of this HTML, I don't know where it is, but anyway, I'll show it to you later. It's just ActiveX commands to go get a cert, and HTML to process this form request. So generate a PKCS10 certificate request. That's the fundamental request format. That was standardized a while ago. How to get it between two parties and what information do you provide, that wasn't standardized. But the actual, here's a PKCS10 request format, was standardized. So it's just the message, the core message that contains my public key. That's what a PKCS10 is.
When you actually install certificate services on a Win2K server, it will install this whole website on your, make it available so that people can request certificates from you.
For auto-enrollment, does the domain controller have to be a CA server in the domain?
No.
So you can segment the CA server to the domain
Yes.
controller. So when a machine is added to the domain, does the machine talk directly to the CA for the auto-enrollment, or does the domain controller work with the
It talks to the CA for the actual auto-enrollment. The group policy drops from the Active Directory telling it to do the auto-enrollment, and then it talks to the CA for that.
Is it a domain name or an IP address or which?
Domain name. It's an Active Directory name. Yeah?
I actually have a question going back to the IPSec tunnel. If I wanted to integrate a third-party service, third-party service, is there a document out there what type of format that service is? Is it a PKCS7 format, or how is that integrated?
Yeah, the step-by-step walkthrough tells you that the contents or the properties of the certificate that IPSec needs in order to use it. So if you go to the web on the Microsoft.com/Windows2000/library and go to the security technologies area, you'll see the step-by-step IPSec walkthrough. So yeah, we test with as many of the PKI vendors as come to the interop events. So for example, Netscape doesn't actually come, but we know people at Netscape and we got certs from them. But that doesn't mean that we can test in all possible PKI deployments. So Entrust comes and VeriSign comes and they have sample certs from different hierarchies and different ways of deploying PKI. We have customers, of course, that have Netscape CA certificates and they've deployed their PKI in a certain way. And so they issue certs off that PKI for the machine, and then we test to see if it works. So it's a gradual process to make sure that every customer, every potential PKI configuration at a customer can be used by IPSec. We know fundamentally there's nothing wrong with the certs and the CAs. It's just how they issue. Right.
And you mentioned that in the next version you'll support pre-shared secret. What version is the service right now? What version will support pre-shared?
Okay, two completely different issues. There's the VPN client, okay, which is L2TP IPsec. So it's the VPN client. And so if I want to look at one, I'll go to Start, Settings, Network and Dial-Up Connections, and I guess I don't have a network adapter. Maybe it'll come up in the plane. All right, well, this is the basic VPN client. If I go into Properties, right, I can go under Networking, and I can choose PPTP or I can choose L2TP, right here. Right? So if I have a certificate and I choose L2TP, then IPSec will try to use that machine certificate to set up the security for L2TP, and that's the VPN client. And in the VPN client in Whistler, this screen will look a little bit different. And instead of, see right now when you choose L2TP, there's nothing else. It's exactly like PPTP. There's no IPSec configuration in here at all, right? So because we generate it all automatically because we can, right? We look in the machine store, we look for the certificates, we build the right list, and we negotiate the right list with the gateway. So the other options here are the gateway address, some tunneling, and include my Windows logon domain, some security things here. I can go into advanced settings, right? I can use EAP, I can request a smart card or something else. I go into properties. I can use a user certificate on the disk. I can use my smart card. There are a bunch of things I can do in here that talk about how to authenticate the user, but nothing in here except for selecting L2TP tells me how to do IPsec because it's all automatic. We felt like the additional configuration would hopelessly confuse most people. Yeah, time. Okay, so in Whistler, this UI will change, and you will have the ability to enter essentially a machine password or a pre-shared key for IPsec. And I've got Whistler dual install in here, so I can take a look at it. I know it's in for beta 2, so I should be able to see the UI in there now. So we can look at that during the break. So that is for the VPN client, okay, that happens to use IPsec. If we go over to
In Whistler, which is
in Whistler
the next
only,
version only.
right? We would like to provide this in Win2K and other
Windows
versions,
XP.
but we don't have, I can't say that we have any plans to do that yet because we're still getting this all working in Whistler. So what we do on the next release, we get everything working in the next release, and then, based on everybody's demand and so forth, we see what we can backport. But we don't necessarily backport everything. I don't know if the VPN guys, because I don't own VPN, I just own the IPsec core protocol, if the VPN guys are going to be able to update the Win2K client. So if I go under IPsec policy, so IPsec by itself, okay, has a bunch of settings, which we'll go into later, but I'll show you very quickly. In the settings, there's a bunch, in a policy, there are a set of security rules. Inside a security rule is the authentication method. If I want to add an authentication method, there are 3 things I can do. I can do Kerberos, I can do certificates, or I can do a pre-shared key. So the fundamental IPsec capabilities in Windows 2000 allow you to enter pre-shared keys. It's just that the VPN client didn't use it because they didn't have a way in UI or they didn't want to build in UI a way for people to put in a pre-shared key. And the reason they didn't want to do that is because it's really insecure. If you've got 4,000 remote access users, they're all going to use the same pre-shared key if you do it in an RFC compatible manner, okay, in a protocol. Some of you may be familiar with VPN clients that use group names for pre-shared key, but again, they didn't care about the RFC. They just extended IKE however they needed. They support this idea of a pre-shared key per group. But we have tried to stick. I mean, we got beat up so badly with PPTP for not implementing IETF standards. So IPSec in Windows 2000 is as standards compliant as we can possibly make it and still make it deployed, right? The only thing we did in Windows 2000 was add Kerberos as an extra auth method, which we documented in the draft, in addition to pre-shared key and signature, RSA signatures for certs. So
Okay.
we're probably out of time.
It's time for lunch now.
Yep.
And when we get back, we're going to go into the in-depth review of IPSec, and we'll actually get into the protocol much more and get into the Internet Key
Yeah,
Exchange.
let me go to the, here's the agenda, right? So we're up here, we just did 10:30 to 12, thank you very much for hanging out with us and going through some of the related technology. Right now, we're gonna do lunch and questions with us. When we come back, we're gonna do more protocol discussion, and then at 2:30, I'm gonna talk about some of the deployment. Now, do you guys have CDs with your packages?
And then our demo's gone.
Okay, the demo is not working because of the Linux
Because
crash.
Linux.
But on the CD, you should have the slides that I'll be presenting with. And you guys got the slides on there too.
Yeah, they're in the book, actually.
Yeah, okay, and they're in the book. So that's the content that we'll cover. I'll leave that up and you guys can just come up to us. No. I mean, eventually.